All right, so here we go, 2.8a, the essential question. Pause it and write it down. How do we perform transformations to equations and function notation? Pretty basic. We're just going to be moving things around a little bit, stuff that you may have done in either 8th grade or maybe even geometry. So a reflection is a mirror image or a flip over a line or an axis. A line or an axis. All right, so the first equation that we have is f of x equals x squared. Looks like that. All right, so we take and negate the whole thing, put a negative in front of the entire equation. Okay, all right, and that is going to change it, and it reflects it over the x-axis. So the new equation, since I put a negative in front of f of x, that means the whole thing, f of x, which is x squared, will become negated. Negative x squared is what produces this graph right here. Okay? So a vertical reflection is a flip over the x-axis. It occurs when we put a negative or we negate, and the key word here is outside parentheses. So outside of the parentheses, that's what's happening. Okay. Take a look at the next one. The graph of f of x equals 2 to the power x. Okay, we're going to write a new equation that we see right over here. But this time we're negating inside the parentheses. So we're only putting the negative and attaching it to the x. Okay, so this new equation is going to be 2 to the negative x power. Notice what happens to this reflection. Okay, we've already got it graphed here for you. This reflection is now reflected over this y-axis here. So that is a horizontal reflection, is a flip over the y-axis, and it occurs when we negate inside parentheses. And that's key that you want to notice that. Okay? So when we negate outside parentheses up here, it is a reflection that is over the x-axis. It's a vertical movement. Okay? When we negate inside parentheses, well, that is a horizontal movement, and it is reflected over the y-axis. Now, to help you memorize some of these, we're going to be using Hicks-Voy. Okay? And here it is, Hicks and Voy, to help you figure out what's going on. So the Hicks stands for horizontal, inside parentheses, and affects x's. So when we are reflecting over this y-axis, it is changing the x values. The y values are not changing. When we are doing Voy, all right, it's vertical, all right, we're reflecting over this x-axis, so it is affecting the y's, and that happens when we are outside of parentheses. So if you take a look at this guy right here, we have 0, 2. All right, when we reflect it over the x-axis, okay, we're using Voy, so it's vertical because it was outside the parentheses, the negative was. It's going to affect the y's. Well, this new point is 0, negative 2. So you can see that the y value is the one that changed. All right, let's move on to the next one. All right, so a translation is a shift up or down and or left or right. So it's a shift. Let me pause this. So again, that's a shift up or down and or could be a left or right. It's just a movement. We're just taking the whole graph and shifting it some way. So we're going to start off with the absolute value curve that we have here. Oh, come on. Smaller. So the absolute value curve is a V, something that you do want to know. Absolute value, all right? The V for value is what it looks like. So here we have f of x plus 3. Well, what are we doing? All right, well, we took the whole graph and we shifted it up 3. Okay? The whole graph moved up 3. So what does that look like for the equation? Well, f of x is equivalent to this, the absolute value of x. So I'm going to replace f of x with that. So it's the absolute value of x plus 3 is the new equation for g of x. And that is the equation that will shift the entire thing up 3. So now let's take a look at what's happening with h of x. So h of x we have f of x plus 3. And this time that plus 3 is inside parentheses. Notice that makes a bit of a difference. So the x plus 3 inside parentheses is going to move it, we'll take a look. The whole thing looks like it moved left, and it actually moved left 3. So this whole graph moved left 3. Okay? So this is going to be the absolute value equation. Oops, come on. Of x plus 3. We're replacing what was inside of parentheses. So it used to be just f of x, and then it became absolute value of x. But when you put x plus 3 inside parentheses, you have to put x plus 3 inside the absolute value, and there is our new equation. Well, I want you to notice something here. When it was outside parentheses, it went up. Outside parentheses, we said was void. It's vertical, it's outside, and it affects the y's. So this was vertical, it went up, right? It was outside parentheses, right? That's how we knew. And it affected the y values. Everything moved up 3. All the y values moved up 3. The x value of 0 stayed 0. This x value of 1 stayed 1. It only affected the y's. So, left 3. Okay, that was inside. So this is your Hicks part. Okay, so it was inside the parentheses. The plus 3 was inside parentheses. It's inside the absolute value. All right, that we count that as inside parentheses. And it moved a little bit differently, though, than we thought. And that's something you have to memorize. When it's inside parentheses, it is actually always going to be opposite what you expect. So inside is going to be opposite. Okay? So plus 3, it's not actually moving it right 3, it moves it left 3. Now let's try another equation here, the square root. So here's your square root equation. It is one of those equations, again, that you need to understand. All right? It has a starting point. It's unique, just like the absolute value up here has a v for value. Square root equations always have a starting point that's unique. So the first thing we're going to do is subtract 2. Okay? This minus 2 is outside of parentheses, so it's going to be outside. We're not going to stick it underneath the radical, so it's going to be the square root of x and then minus 2. Notice it's outside parentheses. We've said that a few times now. So if it's outside, it's going to be void. So we're going to be using void here. So it's a vertical movement, and it affects the y's. So what do you think happened? Well, everything went down 2. Everything shifted down 2. Okay. And then the last one here, we have a minus 2 inside of parentheses. Okay, so it's attached to the x, so we're going to replace this x with x minus 2. So it's the square root of x minus 2 is the new equation that you would get, and you can type this in your calculator if you really want to. And you'll see the graph that we have here. But this graph, again, if you take a look at it, did not do exactly what we thought it would do. Minus 2, most people think it's going to go left 2. They get that inside is a horizontal movement from Hicks. Okay, but you have to memorize that inside is going to be opposite what you would expect. So you think inside minus 2 means left 2, it's actually going to go right 2. So we have right 2. So, keep going. A vertical translation, okay, occurs when we are adding or subtracting outside of parentheses. So, when adding or subtracting outside parentheses. The graph is going to shift up when we add outside parentheses. The graph will shift down when we subtract outside parentheses. A horizontal translation occurs when adding or subtracting inside parentheses, and we're going to use Hicks for that. So the graph is going to shift to the right when we subtract inside parentheses. Again, it's opposite what you'd expect. Subtracting moves it right, which means it shifts left when we add inside parentheses, and that's our Hicks. Up here for vertical, that's going to be our void. Okay, and you want to memorize or star that horizontal is opposite what you'd expect, or opposite the direction of the sign. Okay, so if the sign is positive, it's going left. If the sign is negative, it's going right. All right, dilation is a vertical or horizontal stretch or compression. Taking the whole graph, and we're going to compress it. We're going to take the whole graph, and we're going to stretch it some way. So in the first problem, we multiply by 2. And now, you already know that's the amplitude, and you know what that does. So 2 times the whole thing is 2 sine of x. And the amplitude obviously just got increased, so the graph now goes up to 2. So we have done a vertical stretch here, and we say this is 2 times as far, or 2 times farther from the x-axis. So 2 times as far from the x-axis, because it grew. It stretched this way, it stretched this way, and it grew from the x-axis from the middle. Okay? So if you're thinking about voy, all right, that's vertical, it's outside, and the y values are what's changing. The x values aren't changing, they're just moving it up further away from the x-axis. In the next question, something different happens. We have f of 2x. So we're going to replace the x with a 2x, so we're going to write sine of 2x, okay, thereby changing the frequency. And you know when we change the frequency, that's the number of curves that we will then see. So if we're thinking about it, if that's the number of curves that we see, well, what happened to one curve? That's what I really want to ask. So one curve used to go all the way over to here, okay, if you're looking at that, all the way over to here. So really, it used to stop here, but now it stops here. What we just did is it's half as far from the y-axis. So if we take a look at this point right here, it's half as far as it used to be. The whole curve used to go all the way to here, but now one whole curve is to here. So by putting that 2 inside parentheses, it's not 2 times farther, which we might expect, since this was 2 times farther. It's exactly half. So we're going to say half as far from the x-axis. So from the y-axis, half as far from the y-axis. And again, that's going to be Hicks. We're going to be using the Hicks part of it for that one. So for Hicks, it's horizontal, is inside, so we were inside. And it's the x's that are changing. The y's aren't changing. Nothing up and down is changing in this problem. We are only changing left to right. Moving on to the next one, 1/2 in front. Well, we know with a 1/2 in front, it's going to be 1/2 of sine x. Okay, well, 1/2 sine x. Well, you take a look at the graph. It's just as long as it was before, but it's only half as tall as it used to be. Okay, so the very height is 1/2. So it's half as far from the x-axis. Come on. So half as far from the x-axis. And here's what you don't want to say. You don't want to say it's shrunk, right? Well, where did it shrink? How did it shrink, right? You want to say what it's shrinking in relation to, or what it's getting closer to, or what it's getting farther from. And if we're moving something up or down, right, we're moving away or towards this axis right here, which is the x-axis. When we're moving left and right, we're moving away or towards the y-axis. So that's why we're saying it's half as far from the y-axis. In this case, it's half as far from the x-axis. Okay, well, let's take a look at what happens with this last one. Okay, we're going to end up with sine of half x. Okay, sine of 1/2 x. And you see here, we have this curve. And when we take a look at it, we ask ourselves, well, what changed about the curve? Well, we know that it's going to be half a curve by 2 pi. Okay, so we have a whole curve by 4 pi. Whereas before, we had a full curve by 2 pi. So what happened to the curve? Well, as far as its distance from the y-axis, which is what we're caring about right now, what happened to it? Well, it used to have a full curve, and I'll do that in green. I used to have a full curve by the time I got here. Now I only have a half a curve. So I have doubled the distance. All right, I used to have a full curve by here. Now a full curve goes out to here. I doubled the distance. It is now 2 times farther, or 2 times as far from the y-axis. So this is 2 times as far from the y-axis. And that is key that you understand that, okay? So to kind of summarize what's going on here, when you are outside parentheses, just like it's always been, it behaves as you would expect. The voy, all right? Vertical is outside parentheses. See how this is outside? It's outside of the whole sine curve. The 2 is. All right, and it's affecting the y's. That's the VOY in voy. Vertical, outside, and affects the y's. Okay? If it's inside inside is messing with us, all right? We're multiplying by 2, but it didn't get 2 times farther. It got half as far. And we multiplied by a half, it got twice as far. All right? So what you want to realize here is inside is exactly opposite what you'd expect. So when it says multiply by 2, we actually flip that 2 and we multiply by a half. When it says multiply by a half, we actually flip the half and multiply by 2 over 1, which is just 2. So if it gave us a number like 1/4 inside parentheses, we wouldn't be multiplying and say it's 1/4 as big. It's actually going to be 4 times, all right, as far from the y-axis. It's the opposite. That inside parentheses is miserable. It is opposite what you'd expect. Okay, let's go ahead and fill in this little summary here. So when we multiply a function on the outside of the parentheses by a scale factor of k, okay, the graph is, in this case, k times, so k is our multiplying number, k times as far from the x-axis. Okay, when it's outside, it does exactly what you'd expect. But when you're multiplying inside, all right, by a scale factor of k, all right, which means it's going to be the opposite. So it's 1 over k as far from the y-axis. So again, here is your voy, all right? It should be affecting the y's. When you're saying it's away or towards the x-axis, it is affecting the y. It's moving it away or towards the x-axis, so it's going up or down. And the next one, the graph is 1 over k times as far from the y-axis. Again, this is your Hicks, so it is affecting the x, okay? It affects the x. And don't forget, it's always going to be the reciprocal. You're always going to take inside parentheses and flip whatever it is when you're multiplying. All right, let's move on. Alrighty, so let's go through and summarize this so the video doesn't get really, really long. All right, so vertical transformations to a function can be seen outside, okay? Outside parentheses. Sorry for the noise in the background. Right next to Mr. Klein's room, so that's what you're hearing. Vertical transformations always are the same as what you'd expect. So they always are the same as what you expect. Okay? So to shift something up a unit, so to shift f of x up a units, we're just going to take an add. And since it's vertical, it's voy, right? So vertical should be outside the parentheses and affecting the y, so it should be f of x outside parentheses. We want to shift up. It behaves as we expect, right? Does same as what you'd expect, so it's plus a. If I want to shift it down a units, it's going to be the f of x minus a. Okay, if I want to reflect it over the x-axis, okay, that is a vertical movement, right? These are all vertical movements. Reflection over the x-axis is vertical. It's from up to down or down to up. That's over the x-axis. This is going to be a negation, and that negative has to go, again, outside of the parentheses. Moving on, let's do horizontal. So horizontal transformations to a function can be seen inside the parentheses. Okay, this is your Hicks. All right, inside the parentheses. All right, horizontal transformations are always opposite, okay, of what you would expect. So if I want to shift it to the right, okay, again, it's got to be inside the parentheses for f of x, so it's inside. If I want to shift it right, I'm not adding a. It's opposite what I would expect. I'm subtracting a. If I want to shift it left, again, it's opposite. I would think shift it left, subtract a, but it's opposite, so it's plus a. And if I want to reflect it over the y, you have to realize reflecting it over the y, if you need to draw a picture each time, that's not a problem. When you reflect it over y, you are reflecting it from over here to over here. That is a left-right movement. Whenever it is a horizontal movement, left-right movement is horizontal, it's got to be inside. It will be affecting the x-axis, x numbers. So it's over the y-axis, so that's going to be inside. So that's f of negative, come on, right here, f of negative x. Okay, moving on. Dilations. If the scale factor is a, okay, so if I want something that's a times as far from the x-axis, okay, so from the x-axis, that means I'm changing it up and down. That's going to be my voy, right? So We're using void to solve this one. That means it's got to be outside. Outside parentheses behaves exactly as we expect, so it's just a times f of x, or a f of x. All right, when we are doing something from the y-axis, so 1 over a times as far from the y-axis. Again, the y-axis, that's a left-right movement, so now we're talking about Hicks. It's got to be inside, and inside is always, every single time, going to be opposite. So if I want 1 over a times as far, I have to reciprocalize that, or find the reciprocal. So it's a times the x. Okay? Just to add to that, if it says a times as far from the y-axis, what's going to happen that one? A times as far from the y-axis. Well, again, it's opposite what you'd expect. So what do? Well, you say it's a over 1, and you say it's going to be f of 1 over a x. So if that was a 2, it'd be half as far. If it was, this bad boy was a 3, it'd be 1/3 as far. It's always going to be opposite when it's inside parentheses. All right, so this page pretty much is the summary. You will notice that there isn't a summary for this. So go ahead and get the practice done, and then bring it up.